All right, lesson 25 is on more practice with identities. So last year I only did one video for this, and I felt like my students did not really have a grasp on identities. Although they won't be like super important in Calc 1, they will be pretty important if you take Calc BC. So since many of you guys are, taking pre-calc to get ahead, we wanted to make sure that we really do these well. Okay, so what I would like for you guys to do with this video is I would like for you guys to try the problems first and then watch the video to make sure that you're doing it correctly. So I gave you little hints. So it says students often get frustrated with trig identities. They might take a wrong turn and then 10 more steps than one of their classmates. The more trig identities you do, the easier you will find them to be. So sometimes you can identify these little tricks at the very beginning of the problem. So trick number 1 is rewrite using sines and cosines. So I have several examples of these. So go ahead and try them. So pause and try them. And then you can watch the video and see if you got it correct. All right, so as you remember with identities, you often want to show like the left side equals the right side. So I usually take the more complicated side. So in this case, I would take the left-hand side. And I would first write it, as I said with my trick, using all sines and cosines. Okay, so tangent is sine of x over cosine of x, like that. Okay, so when we do this, we have sine squared x over cosine of x plus cosine of x. Okay, so now often when you have things with denominators, another trick is that you probably want to combine them in some way. So you want to get common denominators. So I'm going to take this cosine of x and I'm going to multiply by cosine of x over cosine of x. So when I do that, I end up getting sine squared x over cosine of x plus cosine squared x over cosine of x. So now that I have my common denominators, I can combine and I can say, oh, well, this is just going to be sine squared x plus cosine squared x, which hopefully you guys all know after the last lecture. And that ends up being just the same as 1, right? Sine squared plus cosine squared is 1. So I have 1 over cosine of x and 1 over cosine, right? The reciprocal cosine is secant of x. So we got it. That was the right-hand side. So we're good. So this next one. Don't be thrown off when I use, instead of x's and thetas, I use b's or betas, right? This is the Greek letter beta. So I'm going to change everything to sines and cosines. So cosecant, as we know, is 1 over sine. And I'm saying divided by sine. And then I have minus cotangent. Well, that's going to be cosine over sine. And then I'm dividing by tangent, which is sine over cosine. Okay, if you're not good at drawing the betas, it's fine. Just put a b in there. It's fine. All right, so that was starting with my left-hand side here. And I got it equal to that. And so when I divide by a fraction, I multiply by its reciprocal. So I'm going to do that in this step. So I'm going to do 1 over sine of beta. And then I have minus cosine of beta over sine of beta times cosine of beta over sine of beta. So it looks like I'm going to get common denominators, right? I have 1 over sine squared minus cosine squared over sine squared. All right, so when I combine, I end up getting 1 minus cosine squared beta over sine squared beta, like that. And if you remember your Pythagorean identity, remember it's sine squared beta plus cosine squared beta equals 1. So if I have 1 minus cosine squared beta, right, if I subtract this to the other side, it's the same as sine squared beta. So I end up having sine squared beta over sine squared beta, which is indeed 1, which is the right-hand side. So we're good. All right, so on our next identity, again, we have more where we're changing things to sine and cosine. So again, you should be trying these first and then watching to see if you're getting it correct. Okay, so I have 1 over tangent of x. Well, that's going to be the same as cotangent of x. So let's say we start with our left-hand side. But we really want to change it into sines and cosines. So you can do the step where you say 1 divided by tangent, which is sine over cosine, plus tangent, which is sine over cosine. And what you'll see is that when you multiply by the reciprocal, you end up getting cosine of x over sine of x, which, like I said, is the same as cotangent. And we don't have common denominators. Okay, so this happens a lot where we have two fractions and we need to somehow combine them. If you notice in our right-hand side, right, we have one fraction. So we definitely have to take these two fractions and combine them somehow. So I'm going to multiply by sine of x over sine of x, and I'm going to multiply by cosine of x over cosine of x. So when I do that, I get, it's kind of weird, sine of x cosine of x over sine squared. Oh, this isn't helping me, is it? What am I doing? See, even I will mess these up occasionally, and that's why I said sometimes you do 10 steps and you really did the wrong thing. Okay, looking at this denominator of sine of x cosine of x. So I don't know why I was doing sine and cosine there. I need to do cosine of x and cosine of x here. And I need to do sine of x and sine of x here. So I end up getting my cosine of x, sine of x on the denominator. So I have cosine squared x over cosine of x times sine of x, or sine of x cosine of x, plus sine squared x over sine of x cosine of x. So I have the common denominators that I wanted, and so when I combine them into 1, I have cosine squared plus sine squared, which we know is 1. So I have 1 over sine of x cosine of x. So that is the right-hand side, and we're good. All right, continuing with this, so tangent, I can rewrite it as sine squared x over cosine squared x. All right, so tangent squared is replaced by that, minus sine squared x, and I'm trying to get it to the right-hand side. Okay, so I started with my left-hand side, it's equal to this. All right, so again, let's try the common denominator route. So I'm going to multiply by cosine squared x over cosine squared x, and I'll just think of that as over 1. So I end up getting, this is where it gets a little bit tricky because it looks complicated when you have sine squared x, cosine squared x, but there's a trick here that we'll do. We have over cosine squared x. So be careful, a lot of students want to cancel here, and you actually can't cancel those. It's just like if you had, let me show you an example, like 1 plus 3 over 3, you can't just cancel the 3's and say that it's 1, right? It's really 4/3. So it's kind of a similar process there. You can't cancel when you have addition or subtraction in between them. You would have to factor something to the front, and that's what we're going to do. We're going to factor the, let's see, the sine squared to the front. So when I do that, I have my sine squared x, and I have 1 minus cosine squared x. And we're actually almost there. It just doesn't really look like it yet. But if you remember 1 minus cosine squared x, if you write your Pythagorean identity, sine squared x plus cosine squared x equals 1, right? If you subtract the cosine squared over, it's the same as sine squared. So what we have is sine squared x times another sine squared x. So you could write sine squared, or sine to the 4th, right, of x. But I'm going to write it like this, because what I'm trying to get to is right here, tangent squared x times sine squared x. So I kind of have a sine squared there. So I'm going to kind of break apart my fractions. So think about it. If I had like 3 times 5 over 4, could I write it as 3/4 times 5 over 1? Sure, right? It's the same thing, 15 over 4, 15 over 4. And that's kind of what we're going to do here. So we're going to take one of the sine squareds with the cosine, and then we're going to take the sine squared, the other sine squared with a 1. So let me write it so you can see it. So I'm going to say sine squared x over 1 times sine squared x over cosine squared x. So if you notice, you have sine squared and then times tangent squared, and that's what we wanted. So I'm going to write it in the order that we see it up there, though. So that's our answer. So that's our right-hand side, and we're good. All right, one more of these, and then we'll do some other tricks. And if you're getting this, you can kind of skip through. It's fine. So this one's a little bit tricky. So again, we have two things, and we want to combine them into one term. So we're going to have things, two fractions, basically, and we're going to combine them. So I'm going to rewrite my left-hand side. Oops, that's a weirdo. As sine of x over cosine of x plus cosine of x over sine of x. So we just did one similar to this. We're going to try to combine. And let's go ahead and get common denominators. So this one has a cosine of x and the other one has a sine of x. So let's get them to be the same and multiply by sine of x over sine of x and multiply by cosine of x over cosine of x. So when we do that, we have sine squared x plus cosine squared x. And they both have the same denominator, so I'm going to go ahead and combine sine of x over cosine of x. So the numerator becomes 1. So this is very similar to what we just did a little bit ago. But now we're going to break it apart. So I'm going to think of it as 1 over sine of x times 1 over cosine of x. And if you notice, that's exactly what I need. See how I have secant of x and cosecant of x? So 1 over sine, that's cosecant. And 1 over cosine, that's secant. So I get my final answer. I get secant x times cosecant x. So that's my right-hand side. Okay, so changing things to sines and cosines is probably the most common thing with trig identities. And you will do that a lot in calculus. But these ones are a little bit different. Okay, so when you see that you have a denominator and you have something that has like secant of x plus 1 or 1 plus cosine of x, something that involves a 1 plus or a 1 minus usually involves the Pythagorean identity. Okay, so this one's a little bit tricky. It says rewrite using sines and cosines and then clear complex fractions. Okay, so it's going to be a little bit complicated. But when we see these 1 plus cosine of x, there's actually another trick that we're going to do as well. So I'll teach that. I think trick number 3 is like that. Okay, so if I have secant of x minus 1 over secant of x plus 1, I'm going to rewrite. So I'm going to say, well, that left-hand side is really 1 over cosine of x minus 1 all over 1 over cosine of x plus 1. And when you have complex fractions, hopefully you guys did a little bit of this in Algebra 2, you can actually just clear by multiplying by the common denominator. So in this case, the only denominators we have are cosine. So we're going to multiply by cosine of x over cosine of x. So when I do that, it's going to go in here, and you're going to have 1 over cosine of x times cosine. So I'm going to have 1, and then I have minus cosine of x. And then all on the bottom, I have 1 plus cosine of x. And you can see that actually gives you the left-hand side, so we're good. All right, so same idea here. If I have cotangent, I'm going to think of that as cosine of x over sine of x. Okay, so now my denominators involve sine of x. So I'm going to multiply on the top and the bottom by sine of x. So when I do that, my cosine over sine times another sine gives me my cosine of x. And then I have minus sine of x. And then on the bottom, I have cosine of x plus sine of x. Okay, so this is not giving me what I wanted. I wanted that 1 minus tangent of x. So one thing that I will do sometimes with my pre-calc class is sometimes I work from the right and the left. So let's try that here. So my right-hand side is 1 minus tangent of x over 1 plus tangent of x. And if I can get it to equal what this is, then I'm good, because I've proven my left hand equals my right hand. It's kind of like working backwards at this point. So I'm going to write it as sine of x over cosine of x. And I'm going to multiply it by cosine of x over cosine of x. So when I do that, I get cosine of x minus sine of x, looking familiar, over cosine of x plus sine of x. So now that these are equal to each other, I'm good. Okay. So occasionally you will get kind of stuck. You'll be like, wait, how do I change this? What can I do to make this better? Okay, what you could also have done though is you could have like divided all of them by sine, or divided all of them by cosine. Actually, I think you divide everything by cosine. So if you had divided by cosine of x on the top and divided by cosine of x on the bottom, cosine over cosine is 1, right? Sine over cosine is tangent. And then cosine over cosine is 1, sine over cosine is tangent. So you could also have gotten it that way. So with trig identities, don't freak out if you're doing it differently than, the people in your class, because maybe you're doing it correctly and they're just doing it a different way. It's not a big deal. All right. So the next trick, it says multiply by the conjugate of the denominator to get a Pythagorean identity. So that's what I was kind of talking about earlier. If you have something like 1 plus sine of alpha or x or whatever, sometimes you can multiply by the conjugate. So this is a very common trick. So what I'm going to do is I'm going to write my cosine of alpha, or you can write a if you don't like the alpha. And I'm going to actually multiply by its conjugate. I'm going to multiply by 1 minus sine of alpha. Okay, so these usually involve like a 1 plus or a 1 minus something. And I'm only going to do it on that left one. Okay, so my left-hand side is equal to that. Okay, so when I do this, I'm going to leave the top factored because a lot of times there's going to be things that will cancel on these. And the bottom, when I FOIL it out, right, first, outer, inner, last, I have 1 times 1 is 1. My outer is negative sine of alpha. My inner is plus sine of alpha. And my last is minus sine squared alpha. Okay, so there's a reason that I did that, because this, the middle terms end up canceling, and I end up getting 1 minus sine squared alpha. Okay, that's important to me. So if you remember, that's part of the Pythagorean identity. Okay, so I have cosine of alpha, and then I have 1 minus sine of alpha. And then on the bottom, I had 1 minus sine squared alpha, which if you write your Pythagorean identity out, sometimes it's hard to see when you're first learning these, I get it. You have sine squared alpha plus cosine squared alpha equals 1. So when you have 1 minus the sine squared, right, subtract it over, you're left with cosine squared. So I end up getting cosine squared alpha. And that's important to me because I had a cosine on the top, which will now reduce. All right, so when I do that, I cancel, I'm left with one of the cosine alphas, and I can combine. Okay, so I have 1 minus sine of alpha, and I have 1 minus sine of alpha all over cosine alpha. So I end up getting 2 minus, oh wait, what did I have here? Oh, I realized this was a plus the whole time. I bet you that was driving you guys crazy. All right, so I have 1 minus sine of alpha plus 1 plus sine of alpha. So I get a 2, the sine of alphas cancel, and I have over cosine of alpha, which is the same as 2 secant alpha. Okay, so that is the right-hand side. All right, so same idea on this next one. So I'm going to multiply the left-hand side by 1 plus cosine of x and 1 plus cosine of x. So I'm not changing it. I'm just multiplying by 1, basically. So I have 1 minus cosine of x over sine of x plus, and remember I'm going to leave that factored because a lot of times things cancel. And when I multiply the 1 minus cosine of x times 1 plus cosine of x, I'm going to have 1 minus cosine squared x. Okay, so my left-hand side is becoming that. All right, so I'm going to have 1 minus cosine of x over sine of x plus, I'm going to have sine of x times 1 plus cosine of x all over sine squared, right? Right, 1 minus cosine squared is sine squared. And that allows me to cancel the sine of x and the sine squared and reduce it out to just a plain sine of x on the bottom. Okay, so again, now I have 1 minus cosine of x, 1 plus cosine of x, so I get a 2 on top over sine of x, which is going to be 2 cosecant of x. And that's your answer. All right, so that trick will happen pretty often. So I have a couple more examples of those. So in this case, I would start with the right-hand side. But again, noticing that you have the 1 minus sign, that's always kind of a red flag that you would like to have 1 minus sine squared. Okay, so I'm going to multiply by 1 plus sine of x, 1 plus sine of x, because that's going to give me that 1 minus sine squared on the bottom. So I have cosine of x, and then I still have 1 plus sine of x. I'll leave it in parentheses, over 1 minus sine squared, which I can rewrite as cosine squared. They all kind of have a similar pattern if you're noticing. And the cosine squared and the cosine will reduce out to a cosine on the bottom. So I have 1 plus sine of x over cosine of x. And this is just the same as if I had like 2 plus 3 over 5. I could rewrite it as 2/5 plus 3/5. So it's the opposite of getting common denominators. It's breaking it apart so that you have common denominators. So I'm going to do 1 over cosine of x plus sine of x over cosine of x, because I saw that I was trying to get secant of x plus tangent of x, and that's exactly what that is, secant of x plus tangent of x. So don't worry if it takes you, twice as long as it's taking me. It's totally fine. I've had a lot of practice, right? So I'm going to have 1 minus sine of x on the top and bottom here. So again, I'm starting with my right-hand side this time because I noticed that I had kind of that red flag, the 1 plus sine of x. Okay, so whenever you have a 1 and a cosine, 1 and sine, even 1 and tangent and so on, like you should probably try this trick. All right, so I have cosine of x, and I'm going to have 1 minus sine of x all over 1 minus sine of x squared, right? Which we know becomes cosine squared, which reduces to cosine of x on the bottom. So I get 1 minus sine of x over cosine of x. So very similar to the last one, just a minus in between. And then that's the left-hand side. Oops, I wrote right-hand side over here, didn't I? Let's say left-hand side. All right. So trick number 4. So it says work with both sides of the equation and simplify each to the same thing. So a chart could be useful. So when I'm saying a chart, what I'm saying is start with your left-hand side and your right-hand side like that, and try to get them to be the same in the end. Okay. So when I have sine of x minus tangent of x times cosine of x minus cotangent of x, I mean, it's kind of tricky. Like, what do you do? So let's go back to that first trick that I taught you, which was changing everything to sines and cosines. So let's go ahead and try that. So I'm going to have sine of x minus sine over cosine. And then I'm going to have cosine of x minus cosine over sine. Oh, kind of tricky. I'm trying to decide if this is the best thing. Let's try one last thing before I do this, actually. Let's combine by foiling first. So I'm going to go ahead and FOIL it out. So I have sine times cosine. That's my first. My outer is sine of x times cotangent of x. My inner is minus tangent of x times cosine of x. And my last is tangent times cotangent, which ends up being 1. So I know it looks complicated, but we're going to hope for something nice. So I have sine of x, cosine of x, and now I'll switch it to my sines and cosines. So I have sine of x times cosine of x over sine of x. So that's what I was hoping would happen, where we would have some things cancel. And then I have minus sine of x over cosine of x. So again, cancel. And then that was, like I said, tangent times cotangent is 1. So we end up having sine of x, cosine of x, minus cosine of x, minus sine of x, plus 1. And there's really not much more that you could do to simplify. You could probably get common denominators and so on, but I'm going to leave it like that and hope that this next thing, when I FOIL it out, becomes exactly the same, and I think it does. So when I FOIL, I get sine of x, cosine of x. My outer is sine of x. My inner is cosine of x. My last is plus 1, which is exactly the same thing as that last one. Let's just write it in the same order. So I'm going to say sine of x, cosine of x, minus cosine of x, minus sine of x, plus 1. Okay, and so I get the same thing in the end. Okay, so I could have done it the other way that I was talking about. Maybe it took a couple more steps. I don't know, maybe it was easier. But for some reason I was like, maybe these things will start to cancel. And like I said, you know, many times you are led astray with identities. Don't get frustrated, just keep trying things. All right. So let's, again, start with left-hand side and right-hand side. So when I see something that involves a square, and so like sine squared, and then sine to the first, a lot of times that does involve some factoring. Okay, so I'm going to factor, which is a little bit strange. I'm sure you guys are not used to this, as that. Okay, and if you check, right, when you multiply sine times sine, you get sine squared. Your outer is plus 1 sine of x. The inner is plus 3 sine of x, which makes the total of 4 sine of x, and then we have plus 3. So it does work when you FOIL it out. And then the bottom, notice how I have that 3 plus sine of x over 1 minus sine of x. So it's a little tricky. It's like, how can I cancel something like this and this? How can I reduce those down so that I'm just left with that 3 plus sine of x on the top? Okay, so some of you might see it. Some of you might have trouble with this still. It's totally fine. What we're going to do is we're going to replace this with 1 minus sine squared of x. Okay, so this is a pretty tricky identity. So when I do that, I'm going to have sine of x plus 3 times sine of x plus 1, and I'm going to have over 1 minus sine squared of x, which will factor. And it factors into 1 plus sine of x times 1 minus sine of x. Okay, it's just like the difference of two squares. Just like if you had 4x squared minus 25, we know that that's 2x plus 5 times 2x minus 5, right? Because it's set up as 2x times 2x and 5 times 5. It's the same concept, the same idea as algebra 2. But when we do that, you notice that this and this will cancel. And then we get exactly the same thing. So the last thing I would do is I would write it as sine of x plus 3 over 1 minus sine of x, just so you can see that they are indeed the same thing. Okay, so you might like the chart setup. That's totally fine if you do that on your test. I'm fine with the chart, or I'm fine with right-hand side simplifying to left hand, or left-hand side simplifying to the right hand. The only thing you can't do is you can't like add and subtract things to both sides. You can't like treat it like an equation and keep things balanced by, you know, cross multiplying or something like that. Okay, so here's another one where it looks like we're going to do some factoring. So I have my left-hand side and my right-hand side. So I'm going to have my sine squared x, and then on the bottom I'm going to have cosine of x plus 2 times cosine of x plus 1, right? So it factors. And then over here I have 1 minus cosine of x over 2 plus cosine of x. So I want to somehow cancel this part right here. So that's when I look to the numerator and I'm like, okay, well I have sine squared x. So if I rewrite sine squared x as 1 minus cosine squared x, kind of opens some doors for me. No, I guess I won't write that one down anymore. Okay, so I'm going to have 1 plus cosine of x times 1 minus cosine of x all over cosine of x plus 2 times cosine of x plus 1. So 1 plus cosine of x is the same as cosine of x plus 1. So I do get the same thing in the end. So my right-hand side equals my left-hand side, and I'm good. I guess I should write that last step. All right. And trick number 5, so it says get common denominators to combine into one term. Okay, so on this one I have 1 minus sine of x and I have 1 plus sine of x, so it kind of brings you back to the conjugate idea. So I'm going to multiply by 1 plus sine of x over 1 plus sine of x. Oops, it's a little messy. And 1 minus sine of x over 1 minus sine of x. So when I do that, I'm going to leave my cosine of x out for just a second. Oops, cosine of x. But I do have common denominators, and the common denominator is 1 plus sine of x times 1 minus sine of x, which becomes 1 minus sine squared x. So if you skip like one step, it's totally fine. All right, so these are all combined into 1. And I'm going to go ahead and multiply the cosine in. So I'm going to have cosine of x plus cosine sine. But then I'm going to have minus cosine of x, and then I'm going to have plus cosine sine. Okay, so my, oops, that one's not canceling, is it? My cosine of x and my negative cosine of x cancel, and I have 2 of the cosine of x sine of x on top. Now, if you look at the bottom, I don't want to have 1 minus sine squared. I'm trying to get to 2 tangent of x. Okay, so I'm going to change that to a single term with my Pythagorean identity. I'm going to make it cosine squared. So when I do that, my cosine of x and my cosine squared are going to reduce out, so I have cosine left. So I have 2 sine of x over cosine of x, and we know sine over cosine is tangent, so we get 2 tangent of x. Oops, right-hand side. All right, so same thing for this one. Multiply by 1 plus sine of x over itself. And I'm going to multiply by 1 minus sine of x over itself. So it's a little tricky because there's a minus in between here, so I'm going to have minus, and then I'm going to put parentheses. So I'm going to have 1 minus sine of x, And then when I multiply 1 plus sine times 1 minus sine, I get 1 minus sine squared. So when I combine, the numerator becomes 1 plus sine of x, and then I need to distribute the negative. So I'm going to have minus 1 plus sine of x all over 1 minus sine squared, which I'm going to write as cosine squared. So my 1 and my minus 1 cancel, and I have 2 sine of x over cosine squared x, which breaks apart into 2 sine of x over cosine of x times 1 over cosine of x, because I'm noticing that I need a tangent and a secant. And that's what I have. So if you see this is tangent, this is secant. So I get 2 tangent of x times secant of x as my answer. Well, not my answer, but that's my right-hand side. Okay, almost done. All right, same idea here. So I'm going to multiply by 1 plus sine of x over 1 plus sine of x on the first one. And I'm going to multiply by 1 minus sine of x over 1 minus sine of x on the second one. So my left-hand side is equal to 1 minus, no wait, it's not 1 minus, it's going to be 1 plus sine of x times 1 plus sine of x. So I'm going to have to FOIL it out. And then I'm going to have minus 1 minus sine of x times 1 minus sine of x. And they're over the same denominator, so I'm going to go ahead and put it together as 1 minus sine squared of x. So when I FOIL, first out and last, I have 1 plus sine of x plus another sine of x plus sine squared. And then I'm going to have minus, and I'm going to put this in brackets because I want to subtract out all of it because this minus is going to go to the whole thing here. So I'm going to have 1 minus sine of x minus sine of x plus sine squared. The worst thing about identities is all the writing. I know you guys, your hands are probably sore, right? So I have 1 plus 2 sine of x plus sine squared of x minus 1. And then that was minus 2 sine of x, so when I do the negative distributed in, I get plus 2 sine of x. Then I have minus sine squared. And a lot will cancel. So my negative 1 and my 1 are going to cancel, my sine squared and my negative sine squared are going to cancel. And if you notice, again, I don't have a 1 minus sine squared on the bottom, so this is where I would change it to cosine squared. So I get 4 times sine of x on top over cosine squared. And we're not all the way done because we want 4 tangent of x secant of x. So that's when we would know that we have to break it apart into those quotients. Right, so tangent is really sine over cosine. And secant is 1 over cosine. And if you check, yeah, you do have 4 sine of x over cosine squared. So we're good there. So that is 4 tangent of x times secant of x. And we're good, right-hand side. All right, and the last trick is to FOIL or factor. So we have 4 examples of those. So on this first one, these ones are a little bit easier. So my left-hand side, I notice that I have a GCF of sine of x, so I pull my sine of x to the front, and I have 1 minus cosine squared of x, which I know 1 minus cosine squared is the same as sine squared of x. So I do get sine of x times sine squared, which is sine cubed of x. So pretty easy one after all those denominator ones. All right, and then same thing here. You cannot just bring the squared in. Don't do that. That's illegal. Cannot do that. So you have to think about it as a separate, as a FOIL problem. So we have sine of x minus cosine of x times sine of x minus cosine of x. And then we're going to do it again. So I have sine of x plus cosine of x times sine of x plus cosine of x. A little messy. So when I do this, I get sine squared x minus sine of x cosine of x minus another sine of x cosine of x. So I'm going to do minus 2 sine of x cosine of x. And then plus cosine squared x. And same thing here, I get plus sine squared x. And then I have plus sine of x cosine of x plus another sine of x cosine of x. So I'm going to do plus 2 sine of x cosine of x plus cosine squared. Almost had enough room. And you'll notice that this piece and this piece cancel. My sine of x plus another sine of x gives me 2 sine of x. But instead of doing that, I'm going to notice that I have sine squared plus cosine squared. That's going to give me 1. And then I have sine squared plus cosine squared. That gives me another 1. So I have 1 plus 1, which is 2. Now if you had done the 2 sine squared x plus 2 cosine squared x, you would just pull out the 2, right? And then you'd have sine squared plus cosine squared. And that would equal 1. So you'd have 2 times 1, which is 2. So we're good there. All right, next up, last 2. I know this is a very long video, but like I said, people had a lot of trouble with it last year, so I want to make sure that you guys are prepared for the test. All right, so we know that we're going to do FOIL or factor on these. So if you notice the left-hand side is something squared minus, or not something squared, something to the 4th minus something to the 4th. So that is the difference of 2 squares. So I'm going to start with that. I'm going to start with my sine to the 4th x minus cosine to the 4th x. So just like if I had x to the 4th minus y to the 4th, I would factor it as x squared plus y squared times x squared minus y squared. All right, so that's what I'm going to do here. I'm going to break it apart into sine squared x plus cosine squared x, and then times sine squared x minus cosine squared x. And when I do that, this whole part is equal to 1. So I really just have that sine squared x minus cosine squared x, which is, again, the difference of 2 squares. So I'm going to factor that into sine plus cosine times sine minus cosine. Actually, no, I'm not, because I want to look at what I'm going to. Don't get factor crazy. Let's see. So I'm trying to go to 1 minus 2 cosine squared. So what if I change this sine squared into 1 minus cosine squared? Okay, then I would have 1 minus cosine squared x, that was the sine squared, minus another cosine squared x, which is 1 minus 2 cosine squared x. So that would be the right-hand side. And the last problem is actually quite simple because it involves what we just did. We would factor into sine squared x plus cosine squared x, which is 1, times sine squared x minus cosine squared x. And we have it over sine squared x minus cosine squared x. So we notice that the top and the bottom cancel, and all of that was 1. So right away, we get that all of it is equal to 1. Okay, so hopefully that was helpful. Again, if you guys have issues, you can always find me in office hours. I am always there to help you. Good luck.